I'm a postdoc at the Norwegian University of Science and Technology. Today I'm going to talk about this work that is entitled Effect of Recycling Powder on the Fatigue Properties of Additive Manufacturing Titanium Alloy. This is part of a larger work involving the Norwegian University of Science and Technology, the University of Cassino and the Italian Center for Aerospace Research about the effect of the recycling powder. Okay. These are the outlines of my work. I will go through the aim of this work. After this I will talk about the materials and methods used, and after this we will go through the results and discussion, the conclusion and the further possible developments for the work. First of all, the aim of this work, of this particular part of the project, was to investigate if the recycled powder can affect the fatigue properties of additive manufacturing components. And in order to do this, we considered three different sets of specimens that were realized. The first one starting from virgin powder feedstock, and the other two sets were realized starting from powders that were recycled according to two different strategies. The first strategy was to consider powders that were recycled more than 100 times. Well, the second strategy was to consider powders that were recycled up to 5 times, not more than 5 times. Sorry. But I want also to go through the reason about for the differences that can arise in the fatigue properties of the additive manufacturing components due to the powder nature. And this is because one of the main advantages that we can find in additive manufacturing is that we can reduce the waste material, because we can reduce the waste material and in order to minimize the costs. But of course we have some additive manufacturing processes that however, you make a use of an higher amount of powder inside during the process, such as the powder bed fusion processes. And in this case, we have that the exceeding powder, of course, can be collected and used again for to build other components. But of course, we have to consider that in the previous processes, the powder have been affected, however, from by thermal history in the building chamber, and this thermal history could affect the morphologies of the powder. And of course, different powder morphologies can result in different defects morphologies, and also in a different roughness for the specimen, that of course can result in different fatigue properties. The effect of the recycling on the powder morphologies have been already studied in another work, also related in the same framework of the same project. That is a work from Bellini et al. That were in which it was shown that the powder after the recycling were showing a different porosity, different roughness, different amount of satellites, different flowability, and different other properties. About the materials and methods used, we have started from some rods built in according to the electron beam melting process. We were considering these titanium alloys, and we considered for each batch of different powders 10 different specimens that were machined to the final condition, and that we have tested at a load ratio of 0.01 and with the frequency of 10 Hz, using an Istron, a multi-axial Istron machine of 250 kN. Even if the tests that I'm going to show you now are only carried out in test condition. First of all, from we have starting summarizing the results in terms of stress range on the nominal net section. And as you can see here, the scatter of the results are quite high. And in particular, if you consider the recycled type A strategy, that was the strategy that we're considering a powder recycled more than 100 times. the scatter of the data is quite high, as it is the scatter also of the virgin powder. This should be addressed to the significant amount of lack of fusion detail defects that we have found on the fracture surface of the test specimen. Indeed, we have performed also a fracture surface analysis in order to evaluate, first of all the phases of the fatigue failure, starting from the crack initiation, the crack corrosion, and the final failure. And in this way, we were also able to identify on the fracture surface the critical defects that led to the final fracture for the specimen. We have considered the Murakami method in order to account for the defect effect, so that we can see the data without the effect of the defects and evaluate if the material itself was affected by the effect of the recycled powder. And we have measured all the values of the critical defects according to the Murakami method, evaluating the effective area for the defects, both for internal defects and external defects. And as you can see, with increasing the number of recycling for the powder, we can see that the average value of the defects, of the critical defects that led to the failure of the specimen was increasing, even if it is also worth saying that the scatter of the defects inside the component seems to be decreased. But of course, these are only preliminary results, and we need to make further studies in order to assess this. If we summarize the data in terms of, according to the Murakami method, considering now the the range of the stress intensity factor, we can see that the data are more in agreement between each other. Indeed, the value of the scatter of the data is significantly decreased, and actually it is already possible to consider all the data according to a unique fatigue curve. And this actually means that we do not expect that the components built from recycled powders and the component built from virgin powders have a difference in terms of fatigue behavior, but of course this is only if we consider explicitly the effect of the defects. However, it is also worth pointing out that for the virgin powder, we have noticed a slight deviation here in the long cycle fatigue regime that we still need to further investigate. So, the conclusion of this work are that the effect of the use of recycled powder on the fatigue behavior additive manufacturing components has been investigated. And the main conclusion is that if the effect of the defects is explicitly accounted for, such as through a method like the Murakami method, we have not noticed a significant difference in the fatigue properties of the component, and in this way we can we do not expect difference in the performance of the two different components. But we also wanted to point out that the specimen built with virgin powder illustrates this slight deviation from the other sets in the higher load levels that we are thinking to explain, to further investigate, maybe also trying to correlate this deviation to the static properties of the material, such as the ductility or UTS, and or to the different characteristics, because another further developments that we are thinking about is that to have a CT scan of all the specimen in order to have the complete distribution of the defects inside the component, and can in order to have a better overview of the defects morphologies inside this kind of components. The last further developments that we are thinking about is to also evaluate the effect of the recycled powder on as-built component, because of course the powders can affect the surface roughness, and as you can see, for now we have only considered specimens that were machined to the final shape, but of course we want to also analyze as-built specimen. Thank you for your attention.
Are there questions from the audience?
How do you recycle the powder?
in Iacoviello?
No, this was done from the Italian Center of Research, Aerospace Research, and I think that they were collecting the powder from other processes, not, I think also from not from building this particular specimen, but also from other components, and then indeed, as you have seen, I was talking about a recycled strategy that considered more than 100 times recycled powder, and another strategy that was only up to 5. So they have some uncertainty also on the number of recycled time, but we had these two strategies.
Yes, and I was involved in this work too. And the type B, they used to refill the powder, they used a particular powder with a low oxygen content for the 5-time recycle.
Yeah, if I remember well, there was a change in the content of the oxygen, and sometimes it was also going up, going higher than the one suggested by the standard.
Yes, the problem is the oxygen content.
Yeah.
I have a question. Yes. So, can you comment on the size of defect with the recycling of the powder? Like you have shown the Mocanu model, so there you must have calculated that area.
Can you repeat the last part of the question?
So you have done the Mocanu model analysis, right?
Yeah.
So can you comment on the defect size with the recycling? Means what is the size of the defect, recognition defect?
In this case, as you can see here, we have seen that with increasing the number of the recycling, because here it's the A type is more than 100 times of recycling, while here it's 5 times for the recycling. As you can see, the average value of the square root of the effective area is increasing. So it seems that for the recycled components we have bigger defects that are however showing a lower scatter. But of course we want to do the CT scan in order to have the complete overview of the specimen, and because this of course is the value of the critical defect that we have found on the fractures to phase area. But of course it's better to have the overview of all the defects.
So this you have done by the crack incident defect analysis, right? Fractured specimen you must have.
Yeah, we have fractured the specimen and then we have measured the defects that was the most critical inside the component.
Okay. Thank you.
Just going back to the oxygen content, did you notice a big difference between the amount in virgin powder and that which was recycled 100 times? Or?
Yeah, this was also said by the Bellini, and the content in the virgin powder, I think it was around 0.12, something like this.
I don't remember exactly.
Yeah, I don't remember the percentage, but I can say for sure that for the recycled powder, for the powder recycled more than 100 times, it was higher than the one suggested by the standard.
Yes, during the process there is an oxygen uptake because even if the process is under vacuum, the oxygen enters in.
And was this under vacuum or under argon?
Can you repeat?
During the printing process, do you know which environment?
It's under vacuum.
It was
Vacuum,
under vacuum. It's the ABM.
yeah.
So under vacuum, not
No, but,
nitrogen atmosphere.
Of course, with this recycled powder, of course the powder will be taken out from the chamber, will be reused and reused again, so you don't have a precise control of the history of the powder.
Yes, the recycling process happens in the atmosphere.
Happens in the atmosphere, so you can have like some kind of modification from the environment, of course. But since one of the main advantages of additive manufacturing is like reducing the waste material, okay, but practically with this kind of processes, you have this powder that needs to be inside the chamber, and if every time you need to start from the virgin powder, at the end it's not, you have the waste material at the end, so it's not the common idea about the manufacturing that is always talked about.
Thank you.
Okay, we have no more time for other
Thank you.
questions. Thank you.